Okay, we are live here with the After School on Monday. Everyone say hi. You can tell they're so energetic. That's fantastic. Today we're talking about all things circles. So I'm going to start off by showing you this video on circle review. I like Bitmojis and I like Snap, so I made this Snap a couple years ago, so we'll take a look at it. This video is on class. So here we have right here the parts of a circle. Hopefully you know that already. Don't forget when you have parts of a circle that a chord goes from one side of the circle to the other. It can also be the diameter. If it's the diameter of the circle, then it's going to go through the center or the radius of the circle. This is not, some of this is not on the paper that you have. This is more of a review. So this is just talking about the parts of a circle. Now within that, remember the center is like the center of attention. That center wants all the attention that's going on. That's why they're in the middle of the circle. The radius is the line segment that connects the center to the outside of the circle. And that is usually what we use for things like area equals pi r squared. The diameter is two radii put together, and they're collinear, meaning that they connect on the same point. A chord is, like I said, the two endpoints are both on the circle. With that, there's like me playing my guitar. I know I got a little excited with Bitmojis. Now, this is me going on the beach. This is how I remember sea camp. I used to live in the Bahamas. If I don't have you, you might not know that. And in the Bahamas, there's no place that you can go. You're like stuck on an island. And so I remember the sea cant as the line that goes out to sea. So the sea cant is the only line that's somewhere on the island, and then it goes out to sea. So that's why I have that picture of we build in a sand castle. Next, I think, is tangent. Let's see. Patience, patience, patience. There we go. There's tangent. The tangent touches the circle at one point. Tangent touches one point. If you don't know that, I'd remember that. That point is the point of tangency. There's some really special things about that. Honey, there's 3 papers. The point of tangency is if you take the radius and you draw a line to that point of tangency, it forms a right angle. Guys, we're still passing around the sign-in, right? Okay. So that's me touching. There's the point right up there. Now we've got central angles. Central angles, the vertex is at the center. Remember, the center is the people who thinks like, man, I'm so awesome. I'm the center of the circle. I got all the attention. Central angle is always going to be big. You're going to use that degree measure with it. It's different than arc length. If you don't know the difference between central angle and arc length, I'm sorry. Oh my goodness, I'm going already to area of a sector. Never mind. The central angle is always the biggest thing. It keeps all the money. Inscribed angles, interior angles, and exterior angles, you always will divide by 2. Central angles are the boss, they keep everything. The formula for central angle, and we'll look at this again, is the central angle equals the degree measure of the arc. For the inscribed angle, we had hand motions that we did. I'm going to ask you to do them with me. The hand motions are arc to angle, we divide by 2. Angle to arc, we multiply by 2. So what we're going to do is everyone, we're going to take our arc, so go like this. This is the arc. Think of like the top of the ice cream cone. You can handle it. I don't care if you play football. God gave you arms to catch footballs and run and throw, so you can use your arms now. Arc, and then when we go to angle, we are like making a division sign. Divide by 2. Then when we have our angle, our smaller piece, our bottom of our ice cream cone, we go back up and do the arc, and then I learned this last year, and then it makes a multiplication sign. So then it's like angle to arc, we multiply by 2. Basically, think of this. If you look at ice cream at Brewster's, the top of the ice cream cone's the bigger part, right? So you're basically going to have the big to small, you're dividing by 2. Small to big, you multiply by 2. Inscribed angles, the vertex is on the circle. It's on the edge of the circle. So that's where the point is. The inscribed angle formula is what I just told you. Again, we take the big arc and we divide that by 2. Now, here's something really special. We're going to talk about it again. Whenever the inscribed angle is on the diameter, we get 90 degrees. And it makes sense because the diameter is half the circle. Half the circle is 180. 180 divided by 2 will give you 90. Then we've got, I forgot what comes next. I think interior angles. Yep, interior angles form an X. If you have me as a teacher, I taught you this is what interior angles form an X. Turn your hands, that means you add. So we add the arcs and divide by 2. Interior angles form an X, you add the arcs, divide by 2. Exterior angles is kind of the idea of like the big minus the small. So the exterior was typically made with secants and tangents outside the circle, and you're going to do the big arc minus the small arc and then divide that by 2. I think Emmons, if you have Emmons, she says big minus baby arc divided by 2. Again, central angles was the only one that gets to keep all their money. You never divide the arc measure. You will divide it for the other angles. So let's take a look at what you have in front of you. Hopefully, if I did it correctly, it looks like this. So here should be the top of the first paper, right here. Right, everyone see where we're looking? So again, this is the same idea that I just talked to you about. Let's see, is it gonna let me write on it? Oh, I know why. I made it so that I could see it more easily for you guys. That's why it's different. I just realized I never imported my stuff, so let me import it real quick. Basically, if you have the front and back paper with all the notes on it, that's gonna be, I'm gonna say almost your best friend, simply because that has what I consider like the most important information on this particular topic. Now, all I did is to make our lives easier so I can write on it. I converted it so it's bigger. So we'll take a look here. So here's our first one. We've got our central angles. Again, when we have central angles, we have to remember that that arc will always touch the center of the circle, central center. Inscribed angles is inside the circle, and it always forms a point. This is the one that looks more like an ice cream cone. Interior angles, like I told you, form an X. We're going to do sample problems in a second. I'm just doing review one more time. Those X, we add the arcs, divide by 2. So if you didn't know that, is maybe what you're going to write down on your paper is add the arcs, divide by 2. Excuse me, if you choose to distract my students, you will be kicked out. Here we have exterior angles. Here we have this. We always are going to subtract what's inside of it. Sometimes for some students, it's easier just to color in because that way you can see what 2 arcs you want. Here's my first arc. Here's my second arc. Here are 3 very important things, and I would be surprised if the EOC didn't test you on this. These are almost like fundamental geometry concepts. When you have a radius and a tangent, it will always form a right angle. How they might trick you is they might give you a problem where they give you, in essence, this hypotenuse, and see, did you notice that you could do Pythagorean theorem? So that's what this idea is. Over here, for this one, we already talked about when you have an inscribed angle whose endpoints are on the diameter, that forms a 90-degree angle. Here, you'll have an inscribed quadrilateral. I hope you get like 20 of these problems because they're super easy. The only thing that you have to remember is when it's inside a circle, the opposite angles are equal to 180 degrees. This is different than a parallelogram. In a parallelogram, you will never have a parallelogram inside of a circle. It's impossible. In a parallelogram, the opposite angles are congruent. But if you have a shape that the 4 sides inscribed are all, the vertices are all touching the circle, when you go across, they're going to be supplementary. We'll take a look at that coming up in a moment. Again, I wanted to show you this whole idea of the radius and the tangent line. Okay, here we have our right angle. And again, they'll probably trick you by having it be something to do with Pythagorean theorem. This is another fun one, not fun because you love it, but basically if you have 2 tangents that are from the same point, these pieces are congruent. And what you're probably going to see is you probably will see a triangle, and I am not an artist on this, so use your imagination. And inside, you'll see like a circle. Pretend my circle touches all the sides. What they'll do is they'll tell you something like, this measure is 5, this entire measure is 12, and this measure is 7. Let's make it 8. How long is the perimeter? This will be an example of a question you might see. And basically, all they're doing is they're saying, dude, this is a tangent here, this is a tangent here. If this value is 5, that means this part of the triangle is also 5. If this is 8, well, that line right here comes out from here. So this is 8, this side has to be 8. And then you just have to use math here. If this whole length is 12, and here there's only 5, how much is left? 7. So if this is 7, this becomes 7, and then we would add up all the sides to get the perimeter. So also, this is gonna, I will try to upload this document as a PDF into YouTube in the comments, or give you a link, so if you don't get all the notes, you'll be able to get it from there. So here we would just add it up. Here we've got 12, here we have 13, here we have 15. Oh, look at that, 30. Isn't that beautiful? So they might not ask you a question as simple as to the picture, but they could very well ask you a question that's got a circle that's inside of a triangle and see if you know the pieces. Okay, then we've got segments. For segments, anyone need this for 30 more seconds? We're good? Okay, here we have segments of a circle. For segments of a circle, we remember part times part equals part times part. And so basically it's saying, okay, right here where they intersect, that's our money point. So when I say money point, I mean that's like a very important point. So what you're gonna do is you're gonna say, okay, well, this piece right here times this piece right here is going to equal these two pieces. And we're gonna do a couple problems together with that coming up. This one is the one where I tell the story of Sleeping Beauty. If you don't know Sleeping Beauty, she was a princess named Aurora, and she pricked her finger on a spinning wheel. Now, my students already know, what would a person typically say if they prick their finger on a needle? Ow, and that's the formula for this, ow. Outside and whole. So here, this says whole external, they did we, but I think it's easier to think like, ow, I just pricked my finger. Look at all these little drips of blood coming down, ow. It works for both. So you're gonna do this outside piece times this entire piece or whole piece time equals this outside piece times this whole piece. That also works if you have right here on your paper, if you have tangents. And so all that would happen is like for letter A, my outside would be the letter A, and my whole would also be the letter A. Nothing changes from there, okay? Couple more, and then we're gonna get some questions going on. So, sugar shoots, yep. Okay, here you probably will get a question like this. They're gonna be tricky when they do this. What they'll probably do is, well, what the formula says is if you have two parallel chords in a circle, they create congruent sections. So if this is 70, this also has to be 70. That's what the formula says, okay? And it kind of makes sense. It's like if you're driving, not that y'all get your driver's license yet, but let's say you're driving down 78, unless it's construction right now, it's like the highway is 4 lanes here, it's the highway is 4 lanes there. It intersects the same amount of space. What they'll probably do is they'll probably do something where they say, you know what? Well, if this is 70 and this is 70, maybe they'll say, how much is this piece? And so they'll give you just that one part, and then you're gonna be like, oh, I know this. X plus 70 equals how many degrees? Well, yes, you can do 140 plus X. What's the total that it equals altogether? 180. Why is it 180 degrees? It's a circle, it's half of a circle. What's the fancy name? Semicircle, okay? So then, as Price was just helping us, 70 and 70 is 140, and then we can subtract and we can find that missing piece is 40 degrees. So they could do something like that for you. Again, another thing is, if you have this right here, we were dealing with parallel chords. But maybe you're not going to get parallel chords. Instead, they might give you congruent chords. And when you have congruent chords, pretty much what I like to do is I like to think about coloring these in. And when you do congruent chords, you're going to end up getting congruent sections, which means this arc here and this arc here are the same. Now, they might trick you. They might tell you these two arcs are the same. That means you have to figure out, oh, if the two arcs are the same, then the two segment measures must also be the same. Here's another one. This is where they're going to trick you with our good favorite Pythagorean theorem. That's going to come up like all the time in geometry. A squared plus b squared equals c squared. You'll have that on your formula sheet. If you have a diameter or a radius, because really remember a diameter is two radii put together, and it's perpendicular to the chord, like here, that means each of these pieces are going to be the same measure. They're going to be congruent. And so what they'll do is it's like they try to trick you. And if I love it when they try to trick you, because then you're just like, dude, I got this. What are you trying to do? So here's my radius, right? So here's my chord. And they might tell you something like this is 7 and this piece is 5, and they want to know like what's the radius. And you're like, dude, I can't figure out how to get the radius. Well, you know what? So many times we think of the radius going straight up, down, left, right. The radius, remember, is any distance from the center of the circle out. So now we just have to do x. And then we can use our Pythagorean theorem and say, okay, well, this section's 5. This section is 7. 5 squared plus 7 squared equals my x squared. And I know it's going to be equal to x squared because it always is equal to the segment that's opposite the right angle. Here's my right angle, because the rule is that a diameter or radius that intersects a chord forms a right angle. And if it forms a right angle, it bisects the chord. So then I've got 25 plus 49 equals x squared. Add these up, and then you'll take the square root, which I'm not going to use my brain to do right now. You're probably going to get like 8.5 if I had to give a guess. Okay? Yep, I got you. We good? Okay, let's go on. We're almost to questions. Couple other things. This is the official formula for arc length. It is on your formula sheet. Theta, you guys are doing great. Stay quiet, please. Theta is the angle you're talking about. Theta will always be a central angle whenever you do arc length or area of a sector. We're good. So please make sure that your teacher might have given you this formula. That's if you use radians. I didn't teach my students that formula. I taught them what's on the formula sheet, which is 2 pi r. On Thursday, when you signed up, you're going to get a piece of pizza, and the crust of the pizza is the arc length. Inside, where you have the pepperoni and cheese, that's the area of the sector. So you have to see the difference. Arc length, area of a sector, and then you're going to compare from there. Okay? Again, this is what they give it to you in radians. This is what you'll see on the formula sheet. All right. Perfect. Let's do some questions. Now go to the page that looks like a much better copy than this one. Let's see. Because for some reason I found the paper copy, but I did not find the digital copy. All right, we're not going to do all these questions, but let's just put some of our stuff to work and see what we come up with. If you already feel confident with the material, you can work at your own pace right now. Like, you don't have to follow along with me. But if you struggle with the content, we're going to talk about some of the problems. Your version is a lot cleaner than mine, and all I ask is, excuse me? All I ask that if you choose to go ahead, just go ahead silently. Please keep your mouths quiet so that way, 1, you don't get picked up on our microphone for our YouTube live stream, and 2, you don't distract the people around you who want to stay focused. All right, so let's look at number 1. What do you notice about number 1? What are the 2 lines coming outside? It would be secants if it went through the circle also. Tangents. And what do we know about 2 tangents that come from the same point? They're congruent or equal. Excellent. So for this problem, all you're going to do is do 12x minus 4 equals 2x plus 2, and then you would solve the problem. I'm not going to solve the problem because I want to cover as much content as I can and respect your time, but at a minimum, please write that down. Or I can go fast. You want me to just do it fast? If I take it slow, I won't have enough time. So I'm going to subtract 2x from both sides. That gives you 10x minus 4 equals 2. Do I have? I don't. Then I'm going to add 4 to both sides. Let me make sure I'm doing it right. Yep. 10x equals 6, x equals 0.6. Okay, number 2, what do you notice about these two angles? Tell me about this angle right here that I just made a big black dot. Is that inscribed the circle? Okay, tell me about the dot. Tell me about the other angle. What type of angle is the one with the red dot? Where is it located? Excellent. It's located in the center, so it's central. So this is actually a 2-step question. First, we know this is 50 degrees. So if I color in a blue ice cream cone, our hand motions were angle to arc. What do? Small to big, multiply by 2. So now we know that the distance from here to here for this arc is 100 degrees. So the middle part is also going to be 100. Excellent job. Why is the middle part going to be 100? Because exactly, central angle same. The reason why the middle angle becomes 100 is that was the picture I showed you with my little bit emoji with all the money. The central angles, the center of attention, they get all the money. Think of like Beyonce or whoever. She gives all her money. She's not sharing anything. Well, I don't know. Jay-Z might have something else to say about it. But nonetheless, central angle same. Okay, let's take a look here. We're going to go straight across. Number 7. Here, even though it's on the circle with the tangent, because this says 117, we're still going to do angle to arc, we multiply by 2. So we've got 117, we multiply that by 2, 234. That tells me, sugar shoots, that tells me angle 1, or arc 1. Yes. Yep, I got you. I got you. If we can't get everything done today, then I'll just post something on YouTube later. So let's try to get you to understand this. So this arc is 117, or this angle is 117. The angle's vertex is located on the circle, so we know that this baby is inscribed. We know anytime we have an inscribed angle, we're going to take the angle and multiply it by 2, because angle to arc, you multiply by 2. So we've got 117 times 2. Sugar shoots. That gives you 234. So that means from this point right here, curved all the way down, is 234 degrees. Who has an idea about how I can find this blue arc? Subtract from 360. Why am I subtracting from 360? It's a circle. Excellent job. That gives me 126. But it wants this angle. So if I know that arc is 126, how much is left for this angle? There's 2 ways you can do it. Excellent. Yep. There's 2 ways. One, you can do 126 divided by 2 and get 63. Or, who's got the other trick? Yeah? 117. Yes, excellent job, Ethan. This is just a straight line. So really, we didn't have to do all that extra. We could have just done a straight line that's got 180 degrees, subtract 117, and then get 63 that way. Any of those ways would get you that information. Okay? We're going to move on to number 9. Yes? What's your question? Okay. So number 9, what type of angles are number? Yep. We will, I'm just like, because it's on the screen, we'll go back. I'm trying to get all the angles done first, and then I'll address the right angles. I got you. Let's look at number 9. I'm trying to get all the angles addressed at one time. What type of angles are this one for number 9? They're inside angles form an X. What do? We add the arcs and divide by 2. So we're going to take 131, add 33. Excellent. That gives us 164. Why is it 82 and not 164? We got to divide by 2. The only angles we don't divide by 2 by are the ones that have tangents, yes, for the 90 degrees, but central angles. Okay, so this gives you 82 for here. All right, I'm going to jump down. I want to show you number 12. I'm trying to get all the angles done first. So now everyone see where we're jumping to number 12? Where are my tools? Okay, so for this one, I don't know why my tools disappeared. Okay, there they are. For this one, what we're going to do is, what's different when we look at number 12 compared to when we looked at number 9? Who notices something that's different with question number 12? There's an X, and one of the X's is where? Outside the circle. So what we're going to do is, when it's outside, you still follow the same idea. We still are going to say X plus 41 divided by 2 equals my angle measure. What do I need to do to eliminate that divided by 2? Multiply by 2. If I multiply excellent by 2, these 2's cancel. And then if I multiply this by 2, now I've balanced my equation. So I'm left with X plus 41 equals 47 times 2 is 94. I'll subtract my 41, and I'm left with 53. If you feel like I'm going fast, you are right. I'm going fast, okay? This video is being live streamed, and when you get home, you can rewatch it and pause it like you want, and I've got other videos where I go more in depth. So I am going fast, okay? Next one, let's look at number 13, and then we'll go to the ones on the other side of the page. For this one, another problem that we've got some issues going on with 13. We know that if I color this in, the 2 angles that I need, sugar shoots, the 2 arcs I need is 120 and this piece here. But I don't know what that piece is unless I subtract first. So you got to think, there's 360 degrees in a circle. If you, yeah, excellent. You can add all 3 of these up, subtract it from 360, and that'll give you this missing piece. And then from there, that's when you'll subtract and divide. Do you guys need me to show you how to do it? Okay. We're going to move back over to here. For 3 and 4, this is something really simple. This is just making sure, because this is the center, that you realize that all of these pieces equal to 360. And because they give you the word diameter, you know diameters equal how much? Half of 360, which is 180. Yep. Here's an example again of using a squared plus b squared equals c squared. And basically, it's testing you because of the word tangent. So that's not too extra that you need to do. Okay, those are just inscribed. Let's see. All right, let's look at this piece, 15 and 16. Now, they look like interior angles. And if we had, I'll wait. Not just you guys, thank you though. It looks like interior angles, but they don't give us angle and arc measures. So for that reason, they're actually segments. And so this is where we do the part times part equals part times part. So this piece where they intersect, that's our money point. So we're going to do 3 times x equals, can someone tell me the other numbers? I can't tell. for 15? Thank you. 9 times 5. So 3 times x is going to give you 3x. 9 times 5 gives you 45. And then divide. You guys should hopefully know that from algebra. Okay, another example here. This is the ow. Because look at that point outside, like I totally hurt my finger. Ow. So when you do this, the easiest way to do it for me is I just write OW on the top, OW on the bottom. Out here, my outside piece is 3. What would my whole piece be? X plus 3. Excellent. X plus 3. Why is it x plus 3 and not 3x? What's the difference between those two things? You're adding them. Fantastic. What would I get for down here? What would my outside be for this one? 4. And what would my whole piece be? 4 plus 7, and I'm just going to write 11. We can do the actual math. Okay? Now, what do I do now? Who remembers? What does the ow mean? Football team, I feel like I lost you. Okay. Outside hole. So what do I do? Do I add the outside hole? Do I subtract? Excellent. So now I'm going to do 3 times x plus 3 equals 4 times 11. Yes. Because the whole is if you add all of this up. It's like you have $4 in one pocket and $7 in your other pocket. How much money do you have altogether? 11. And that's the same way we got x plus 3, because we have $3 in one pocket, x in the other pocket. What do? Add them up. Okay. Here you have to remember to distribute. So you've got 3x plus 9. Here's 44. I'm going fast on purpose. This gives you, sugar shoots, 35. Divide, thank you, smart move. And then that gives you whatever. Okay? It's going to be a decimal. I'm not going to do that work. Goodbye, sir. Everyone say bye to Mr. Austry. Okay, let's go on to the second side. Okay, let's see. This isn't going to let me turn it, I don't think. All right, we're going to move on. This stuff, I don't know how many questions will be on the back of that, but I feel like if I don't cover circles, you guys are going to be in deep trouble. So go back to this paper, the side that says equation of a circle. Couple things to deal with the equation of a circle. This right here, this x minus h squared, y minus k squared equals r squared, that is on your formula sheet, okay? That is the equation of a circle. This I got from the top of this page. You really should know, if you have papers like this, if you know sugar shoots, those papers, you will be really set. Like if you know the papers and how to use it, you will be good to go. Couple things. Anytime you have the center of the circle, it's always the opposite signs from the equation. See how here it's positive h, positive k in the middle? Here it's negative h, negative k. It switches. The other thing is, anytime you go from the radius is always squared inside the equation. Here it says just the letter r, but up here it's r squared. If you're given the center of the circle and a point, you're going to use the distance formula to find the radius. And I have a trick for using the distance formula. I'm not going to go into detail about how to use it, but you'll probably see me to use it. That's what the distance formula is. If you're given the diameter and they want you to find the center, that's when you're going to use the midpoint formula. Did everyone sign in today? If you did not sign in, can we pass that sign-in sheet to make sure people have it? Okay, again, you have your center and your radius, okay, and then you're going to use the midpoint. All the midpoint formula is add x divide by 2, add y divide by 2. We'll look at some questions in a second. Here, you're going to, if you get a question, which you will get, on is it inside, on or outside, you're going to use the distance formula again and compare the radii. And then it tells you how to do slope. So let's open up our last thing. You're gonna go to the last paper that says circle something, something, something. You'll see it. Circle something, something, something. It's the last one that we haven't touched yet. Yes. Okay, it looks like this. So let's take a look at some of these problems. First, it wants us to write the equation of a circle. There are a ton of problems. This isn't multiple choice. I'm just going to give you an overview. Please, we're leaving at 3:20. I need your 100% focus for 10 more minutes. Okay, you will get brain breaks on Thursday, but because we're just meeting for an hour, we push through. So I need 10 more minutes of your best, and then you guys are free to go. After you clean up the space, some of y'all left trash last time. I was kind of disappointed. Okay, anyway, so yes, they spelled the word center wrong. I picked this up from a different site, not a US site, but it works. See here how it says the center is 0, 0. Anytime the center is 0, 0, all you're going to do is just do x squared plus y squared. That's it, because x minus 0 is x, y minus 0 is y, and then the formula says you square the radius. So here my radius is 5. 5 times 5 is 25. Done. That's literally all this whole thing is. Here I've got the center at +1, +3. Anytime we go from the center to the formula, we always flip the signs. So here we've got x, we have +1, so this will be -1. Here we have +3, so now it's -3. Square the 2, 4. Done. Now, I do want to go look at letter F. What's different about letter F compared to the other ones? Yes, the radius has a radical. So let's talk about how to square things when the radius is a radical. This is the same thing as saying 2 square roots of 3 squared, which is the same thing as saying, well, 2 square roots of 3 times 2 square roots of 3, which is the same thing as saying 2 times the square root of 3 times 2 times the square root of 3. I'm going way more extra than you need. Here I've got 2 and 2. 2 times 2 is what? 4. And then here I've got the square root of 3 times the square root of 3. Well, when I do that, I get the square root of 9. But what's the square root of 9? 3. So the answer is 12. So this is what you do. This is the quick, that's the long way. So write it down if you don't know it, and here's the quick way. 2 squared times the square root of 3 squared. 2 squared is 4. This square root of 3, all it does is cancel this stuff out times 3. And that's how you get the 12. So if you were to do this officially, the answer would be x plus sugar shoots 3 plus y minus 9 equals plain old 12. So if you remember from the midterm, I'm sure your teachers went through it with you, that was one of the questions we got wrong, is because the radius was a radical. And what we did is, so many of you forgot that when you square a radical, it's just the number inside. And that's what that piece is. If we go down to this next section, here you just do the opposite. Here we notice that there's no numbers next to it, so my center is going to be 0, 0, and I take the square root of 16, and I get 4. For F, you probably could do a decimal or you could reduce it. Okay? Now, I do want to show you down here. So everyone look down here, and we're going to look at numbers, letter C, 3C. Everyone look at 3C, because if you don't know how to do this, you are going to probably miss at least 2 questions on your test, and I don't want that to be you. So let's look. Your best for 6 more minutes. You got this. When you have something like this is called the general. This is called the general form of a circle. We're trying to convert it to what's called the standard form. When you convert it, the way I taught my students is I said first you group the x. So I've got x squared plus 12x, and then I leave a space. Then I look at my y's. I've got y squared minus 8y, and then I leave a space. And then the last step is you take whatever this number is, in this case it's positive 36, and you bring it to the other side. So the opposite of adding 36 is subtracting 36. So this is going to equal negative 36. Who remembers from my class what we do next? Excellent. You divide by 2. What do I divide by 2? The 12. So what am I going to put inside? 6. What goes up here in this space? 36, because we have to square it going back up. So basically you're going down dividing by 2, up squaring it. If you put a 36 on this side, we also have to put a positive 36 on the other side of the equation. Here, I do the same thing. I set up my equation of a circle. I divide by 2 going down. Negative 8 divided by 2 is negative 4. And then I square going back up. Negative 4 times negative 4 is positive 16. Here's a tip. Your calculators on the EOC suck. I shouldn't say it like that, but they do. So you might have to put parentheses or figure something out. You're going to have to remember a negative times a negative is positive. When we do that, we add all of this stuff up, and that gives us 16, because these will cancel. Switch the signs. Our center is negative 6, positive 4, and our radius squared is 16, which means our radius is 4. Let me go through this last one. I've got 3 minutes. You can handle 3 minutes. This last one, it tells you the center passes through the point. It wants this. Because it gives you the center, you're going to use the distance formula to get the radius. So write down here, distance for radius. Here, it gives you the diameter. So you're going to end up having to do a midpoint to get the center. So I'm just telling you what you need to do. I would write it down so you know how to do it later if you want to look at it. For the first one, it's going to be the distance. You're going to use the radius for number 4. And for number 5, you have to use the midpoint formula. Number 6 for in, on, and outside. Let me show you this real quick. You will always just compare your information. Compare it using Pythagorean theorem. 3 more minutes, you can handle it. Here, I know looking at this that my radius is what? Please don't say 64. 8. Watch what you can do. Because in this particular case, there's no other numbers, it's just x and y, so we know our center is 0, 0. All we're going to do is just do 0 squared plus 9 squared equals x squared. That gives you 81 equals x squared, 9 equals x. So you have to say, is 9 bigger or smaller than 8? Bigger, so that means that this point is outside. So sometimes, usually you would have to do the distance formula, but in this case, we really didn't need to do the distance formula because we knew what the center was. For these problems here, we would have to first find the equation and then do it from there. Okay, so we're going to end here. Don't get up and listen. On tomorrow, Tuesday, we are doing odds and ends. Odds and ends is trig, which is 15% of your test, probability, volume, and density. On Wednesday, there's nothing. On Thursday, we will start serving pizza at 2:12. You get 2 slices of pizza. Don't get up yet, wait. If you did not sign up, you will not get food. We are starting the learning at 2:30 to be done at 4 o'clock on Thursday. All right, I have 17 calculators left. Return my calculators, clean up your mess, don't make me do it, and I will see you tomorrow at 2:20. Excellent job, well done. Excellent.
Oh, by the way, how much percentage is the tax about the stock market?
15% on two.
They're not signing if I sign up.
And what is the majority of the tax?
You can put it right there. Yep, and what days are coming?
All of them.
And do you mind that telling me what the majority of the test about?
We'll go over it. It's on equations. Congruence and similarity is 30, and then equations quadratics. Calculators! I'm still missing 10 calculators. Look around, tell your friends, let's go.
Pen doesn't even write. I thought you said you had a short. Right. Oh, all these work for all. Erie. I have a question. Is this done with the live square? Yeah.
Can I borrow the keyboard?
Or
I think I'm going to put in one of the keyboard. I think I'm going to bag.
can I give you my keyboard? My key doesn't open up.
Okay, should we go into another meeting?
Oh, you need to leave the building or else I'll get in trouble. So find a place to go because I got yelled at on Tuesday because I tell you this. So find a place to be, but it can't be here and it can't be up here, so go somewhere else. That's fine. That I talked about on last week Tuesday, so that YouTube video is online. I do. If you text my name at Irig, you'll get on my remind.
So let's see, so on the table, and I cleaned up what was left of the mess on my table.
Thank you.
See you tomorrow.
All right. Nope. I just realized I'm still recording, so I need to stop.